Hello and welcome. Today I'm going to answer a popular question from students, and that is, why is it that when we take the integral of 1 over x, we end up with the natural log of modulus x plus c? Because that's not what we learned in secondary school. Let's take a look at something else first. Here is a simple graph, y equals to x squared. Now, the question is, would you consider this red graph to be y equals to x squared? What I did was, I only allow x to be more than 0, and we only got the right-hand side of the x squared graph. You might be thinking, what has this got to do with the question? Well, we're going to that very soon. Here is the graph of natural log of x. Another cool feature of Desmos is that, do you know that Desmos can do differentiation for you? Say if I wanted to differentiate natural log of x, just let natural log of x be a function, say f of x, and in the next row, plot the graph of f prime of x, and voila, there you have it. The graph in blue is the derivative of the natural log of x. And if you have some difficulty recognizing the shape of this graph, do not worry. I'm going to show you algebraically what is the derivative of the natural log of x. And if you remember how we got the derivative of this, the derivative of exponents. So I'm going to take exponent on both sides. This is what I have. The right hand side just resolves to x because those are inverse functions. And then I'm going to differentiate this entire equation with respect to y. Now the left hand side is easy, right? The derivative of an exponential function is just the exponential function itself. And over here we have dx dy. I want dy dx. We can actually just take the reciprocal on both sides. Dy dx is just going to be 1 over e to the y. Again, I want the derivative of this in terms of x. And here I have something in terms of y. A quick substitution will do, and that will be 1 over x. Yeah. So the derivative of the natural log of x is 1 over x. But you might be thinking like, wait a minute, this blue graph does not look like 1 over x. In fact, 1 over x looks like this. Now I get what you're trying to ask in the first question. This is just the right-hand side of the graph of 1 over x. It is 1 over x, but with the domain restricted. What we have learned since secondary 3 was not complete. The derivative of natural log of x is 1 over x, but with a restriction, and that x must be more than 0. So when you differentiate the natural log of x, you do not get the full 1 over x graph. You get only half of it. When you are integrating the full graph, you're going to get two functions. The positive side, the blue one, will give you, well, what we always known to be true, which is the natural log of x plus c. And the other side will actually give you natural log of minus x plus c. Let's do the integral of the whole thing. I don't want any restrictions on the domain, except that I know that x cannot be 0 because I know the graph is not continuous over there. What I'm going to get is a piecewise function when x is more than 0, and when x is less than 0, I'm going to get this. Wait a minute, I know this. This is the natural log of modulus x. So that's the reason why I write the modulus sign over there. Thank you for watching, and I hope to see you in the next video. So until then, I'll catch you on the flip-flop.